Today we're looking at integrating composite functions. Pace?
I'm nervous now. No.
What is a composite function?
Good chance.
What's a composite function? Check Pace.
I'm nervous. I can't think.
Chance, what's a composite function?
A function inside of another function.
Is that Lauren?
That was Lauren. I'm going to give her the credit.
I took credit for that.
Alright, Lauren.
You already said it, so I'm
Thanks.
Let the record
So-
show that Lauren had the answer.
Yeah. Alright, so we're integrating functions that have functions inside of another. That's what we're doing today. Okay. Alright, so. And just like all the other stuff we've integrated, before we integrate, what did we do? Before I learned how to integrate, what did we remember to do? How to take the derivative, because how are the two related? They're opposites. So, we want to remember how to take the derivative of a composite function. Now, why is this a composite function?
There's a function inside of another function.
G is inside of that.
Yeah.
So, how do I take the derivative of a composite function?
F,
Sure.
F prime of G of that
So, I take the derivative of the outside,
times G prime.
not times G prime of x.
Times.
Oh, yes. You're getting ahead of me.
Yeah.
So, derivative of the outside, the inside stays the same, and then times the derivative of the inside.
So just like a chain rule.
Yes, it is a chain rule. I take the derivative of the composite, I'm using the chain rule. That is correct. So that means that if I integrate that thing right there, what am I going to get?
F of G of X.
I'm going to get f of g of x. So, I want you guys to look for a pattern there.
You've got the prime on the outside, so you know it's going to be on the inside.
The
Well, so you have f prime of g of x, and then it goes to g prime of x,
Right.
so you just kind of smush it all together. You have that multiple.
Alright. Anybody else see a pattern?
whatever's
The
on the
primes
inside,
cancel?
take the, or if you have, because whatever is your inside function, it's got to have a derivative, like in that case, correct? Because it derived from the chain, so you know that it's. I don't know how to propose this.
Anybody else?
we were thinking the same thing, but I can't figure it out.
Yeah.
So if I look at this, and I look at that, what is it that is actually integrated? Because there's only one thing that was integrated. There's only one thing that was integrated.
The F.
The F.
Yeah.
F is the only thing that was integrated. Because I went from F prime to F. So that means the function inside, what has to be present of the function inside if I'm going to integrate?
It's derivative.
Its derivative. So if the derivative of the function inside is present, all I have to worry about integrating is
F.
the outside
Or
function.
outside.
So the only thing I have to worry about integrating is the outside function. So if I've got a composite function, first thing I'm going to do is identify what's the outside function, what's the inside function. Then I'm going to look for the derivative of the inside function. If the derivative of the inside function is there, then all I have to do is integrate the outside function and keep the inside function there. Follow me?
Would there be a time where the inside function does not have a derivative?
Yes. And we'll deal with that. Okay? So, what we're going to do to kind of to kind of make it easier to work is we're going to do substitution. We're going to take it from a composite function and turn it into a function that's not a composite function. And then turn it back into a composite function. So we'll see how you can handle that. All right. So I have the integral from 0 to 1 of 2x times x squared plus 1 to the third power dx. All right, so the first thing I want to do is identify that I'm dealing with a composite function, and then I want to identify what?
Inside and out.
The inside and outside function. Very good, Josh. So Josh, what's the inside function?
The x squared plus
The x squared plus 1 is my inside function. And what's the outside function?
the
The cube.
2x cubed.
The cube is my outside function.
Oh, and then that's your derivative.
And then that's the other part's going to be the derivative. Okay, so I don't have to, the first thing I'm looking for, what is inside of something else? Okay, the 2x is not inside of something else, so I'm going to ignore it for now. Over here, though, with the x squared plus 1 cubed, it should be pretty obvious that the x squared plus 1 is inside of the cube. Okay? So what we're going to do is now we're going to make a substitution, and we're going to turn this composite function into a normal function, a non-composite function. Okay? We're going to do that, again, by a substitution. We're going to say u equal to whatever our inside function is. Okay? So I said u equal to our inside function. Now, earlier, what did we say had to be true about my inside function? The derivative needs to be present. So whenever I set u equal to the inside function, I need to take the derivative of it. And actually, let me show you how I got to that. If I take the derivative of this, technically, that left side should be du dx, right?
Yeah.
Okay? But then we're going to automatically send it over there. And you'll see why we want to send it over there in just a second. Okay? So what I'm going to do now is I'm going to turn this in to an integral that only involves u, and it's going to turn into a non-composite function. So I'm going to make some substitutions. I'm going to use this to make some substitutions. I'm going to use that to make some substitutions. Okay? So, I need to replace x squared plus 1 with u. So that means this is going to come out and u is going to go in its place. So that gives me u cubed. The other thing is 2x dx I'm going to replace with du. So here's the 2x. There's the dx. So those two come out, and I'm dealing with du. So now I have a function that is non-composite.
Even though it looks like you didn't have the derivative of the inside, you do. You need the 2x.
So now I'm dealing with a non-composite, which we can integrate. So now I want to integrate this. Now notice, and I'll talk about this in just a second. Notice I didn't put any limits on here, and I did that on purpose. And you'll see why here in just a second. So now I'm ready to integrate this thing. So if I integrate u cubed, what do I get?
U to the 4th over 4.
I get u to the 4th over 4. Okay? Now we want to turn it back into a composite. So that means the u has to go away. What am I going to put in place of the u?
X squared plus 1.
The x squared plus 1. Then I can put my original limits back in.
Don't you want
Do you not-
x squared to that one to
Not,
the fourth?
Quadrate it,
You're right. All right. Thank you.
or excuse me,
The fourth power.
correct.
Okay, so now I can put the limits back in there because those limits belong to the variable x. I can put limits in here, but I've got to get limits that belong to the variable u. Does anybody know how I can get these limits right here for u?
plug it into x squared plus 1.
Very good. I plug 0 and 1 into the x squared plus 1, and that'll give me my limits for u. So if I put 0 in here, 0 plus 1 means that my lower limit has to be 1. If I put 1 in there, 1 plus 1 means my upper limit has to be 2. But
You don't.
we don't have to do that. Now sometimes the AP keeps changing things. They want you, because there's a way to do this without actually using u. Okay? But recently here, the AP has been asking, they'll give you a question like this and they'll say, what does u need to be? And then what does it look like when you change it into a non-composite? So they're going to want the limits. Okay? So we're not going to have to put the limits every time, but you need to know how to get them if it's asking for it. So all you got to do is plug into what you've set up on the right. Now here's what I want you to do. After we get to this point right here, I want all that out. All the extra work we did to get to this point, I want to mark it out. Because all the AP world cares about is that you can get from here to there.
Don't care how you got
So you don't care how you got there. So once you do the u substitution, I want you to go back in and cancel that out. Okay? So now all I have to do is plug in 1 and 0. I'm going to put this 1/4 out front though, so I don't have to mess with fractions. So I stick the 1 in there. 1 plus 1 gives me 2. Then I stick the 0 in there. And 0 plus 1, sorry, that's not 2. What should that be? 16. Should be 16, and then that's going to be 1. So we end up with 15 over 4.
That's all you do.
That's it.
Okay, just some clarification. The du is your inside function that you replace?
du is equal to those two pieces over here on the right. So I took those two pieces out and put du in its place.
So is that your inside? Is that your g of x?
It's the derivative of the inside.
So
So that's technically the g prime part. You'll get more comfortable the more we do. So let's try another one. So I want to integrate from 0 to 2, 4x over the square root of 1 plus 2x squared.
Your inside is the 1 plus 2x squared.
Alright, so what I want you to do is I want you to look at this and say this is a composite function, which means I need to identify an inside function. And just as Chance said, my inside function is 1 plus 2x squared. So what do I want to do with my 1 plus 2x squared?
Set it equal to u.
Set it equal to u. So I come over here on the right, and I get 1 plus 2x squared. Or
You need
u
to
equals,
set that all to the 1 half.
slow down.
That's the outside
That's
function.
That's the
out
outside
function.
Alright, so now once I do u equals 1 plus 2x squared, what do I want to do?
du.
Identify derivative of the inside.
Take the derivative of it.
Okay.
So I'm going to get du equals 1 plus 2x squared dx. Okay.
We're not like
Wait,
the
what?
derivative of it.
Sorry. Golly.
Yeah, you lost one.
How about that?
That makes
That looks a lot better.
I like it.
Alright. So now what am I ready to do?
Substitution.
Make some substitutions. So, when I see 1 plus 2x squared, I'm going to take it out and put u in its place. So 1 plus 2x squared is there. I take it out. I put a u in its place. Then, I'm going to look for 4x and dx. If I see 4x and dx, then that means I can put du in the problem. I like to put it on the side, and I'm going to put a 1 there. So, questions on what we did there? So now I went from a composite, I turned it into a non-composite, which we should be efficient at integrating. So what do I want to think of this as?
U to the negative.
U to the negative 1/2. So if I integrate u to the negative 1/2, I get
U to the 1/2.
u to the 1/2 divided by 1/2, which is times
2.
All right. Then what do I do?
Plug back in the U.
Plug back in. So I have 2 times 1 plus 2x squared from 0 to 2.
This is probably a stupid question, but how did the D disappear?
Remember, what is the job of that?
Saying what terms is in.
It just lets me know what I'm dealing with, what variable I'm
Don't
dealing with.
forget to the 1/2.
Say again.
Don't forget your power. To the 1/2.
Thanks, Grace. All right. So once I get back to this point and I turn it back into a composite, what do I want you to do?
F of B minus
X
F of A,
out.
Oh, okay.
I want you to X all that out. Okay? Because if I get to this point right here, but I did something in here they didn't like, they can take off. But if I get to this point, I work that and then I mark it out, they're not allowed to look at it. So if I did something they didn't like, they can't count me off. All they care about again is me getting from here to there. All right, so I'm going to leave the 2 out front. I plug 2 in, so that's 4 times 2 is 8, plus 1 is 9, and the square root of 9 is 3. I plug 0 in, so that's 1 plus 0 is 1. The square root of 1 is 1, so we end up with 4.
Not too bad at all.
All right, so on this next one, we're going to work it, and our derivative is not going to be an exact match. So we're going to see what we need to do there. Any questions on this one before I clear it?
What do you mean the derivative is not going to be an exact match?
You'll see it. So I want to integrate from 0 to 1, x times the square root of 1 minus x squared dx.
Notice that I'm guessing the inside's 1 minus x squared.
That's correct. So I need to notice it's composite, then I want to identify the inside. So yes, usually whatever's inside the square root, if there's something inside the square root besides x, that's going to be your u. So u equals 1 minus x squared.
Is there a way we can alter x dx to make it 2x dx?
We're going to get there, yes. Alright, so I take the derivative, so I'm going to get du equals negative 2x dx. And then as Rachel has already seen, I've got an issue when I'm looking for that, so I can replace it with that. What do I not have?
Negative 2.
I do not have the negative 2. So we've got to do some alterations. And that is, I can put the negative 2 in here, but if I put the negative 2 there, what else do I have to do?
Put it inside.
I've got to counteract it
Divide.
with a negative 1/2 out there. Because what is negative 1/2 times negative 2?
1.
1. So I'm allowed to do anything as long as it results in 1. So if I need it on the inside, I'm going to put the reciprocal on the outside.
That's getting funky.
Okay. So now I've got what I need to make all my substitutions. So that can be replaced with a u, and then the negative 2x dx is replaced with du. Alex? Good? Questions with what I've got? So now I'm ready to integrate. This is u to the 1/2, so when I integrate, it's u to the
3/2.
3/2 with a
2/3.
2/3 out front, and I've still got the negative 1/2 there. I substitute back. I'm gonna go ahead and put these together, so that's negative 1/3. Then I have 1 minus x squared to the 3/2 from 0 to 1. We're okay?
Yes.
Alright, so negative 1/3, I plug in 1 minus 1, that's going to be 0. I plug in 0, that's 1 minus 0, which is 1, and 1 to the 3/2 power is 1, so I end up with 1/3. Now, what have I not done yet that I need to do?
Exit
I
out.
need to do some Xing out. So X that out, X that out, X that out. So I end up with 1/3. Question? Any questions so far?
So what is it that AP readers don't like about that work?
Well, they're going to want to see the new limits there and there.
And that takes time.
And I don't want to take the time to get my new limits. And if I screw up getting my new limits, then they're going to count off. So I prefer doing it to get to where I need to be and then canceling it out. Because I feel like I'm wasting my time getting those limits.
Mr. Short, on the other ones we did, they already had the derivative of the inside for us, right?
Correct.
On this one we didn't.
Right.
So couldn't you just, integrate the power and then tack on what you need, like you did there with the -2, -1?
You can, yes. Not everybody can.
What did he say?
No.
Huh?
But
Maybe I have to
yes,
break that.
I'll get with you later and show you the quickest way to do it. But like I said, there are also going to be multiple choice questions, and I'll show you one here in a second where they want to see you actually do the U substitution. So you can do the shortcut way, which is what you're talking about, but you've still got to be able to show them you know how to do it with U. All right, 2 more.
I'm a fidget.
Oh, here goes Alex's favorite.
All right, so I want to integrate from 0 to pi over 6 sine squared of 3x times cosine of 3x times d of x.
Well, we know this is a composite function. I'm
It
not
is.
sure what the inside
It
is.
is a composite function.
Okay, I do have a question though,
Yes.
on this. Why would we take the time to work it out like a composite function? We could just split it up and work it just as easily.
You cannot split it up.
Because what's inside
Well,
of
not this. Wait,
You can only split it up if
If
it's
it's-
addition or subtraction.
that's why.
Would the sine of 3x be the inside?
Sine of 3x
No,
is
that's-
the inside function.
What?
Because
Because
we got
the
the
square.
square.
Yeah.
Because here's another key in choosing your inside function. Some of us might think 3x is my inside function.
that's would
Correct.
be
So if I take the derivative of 3x, what am I going to get?
3.
3. But if I take 3x out and put u in its place, what am I still left with?
So of course.
Sine squared times cosine. Do I know how to integrate that? No. So that tells me 3x is not going to be my u. So I need to go something bigger than 3x. Okay? And sine squared is the one I want.
That's where's the inside?
Sorry, sine is just what I want. So sine of 3x is what I want. And sometimes that's the hardest part, is figuring out what your inside function is. All right, so I take my derivative. So what would the derivative of this be? 3 cosine 3x dx.
Yeah.
So now I need to make sure my derivative is there. Is all of my derivative there?
Not the 3.
No. So that means I need a 3, which means I have to put a 1/3. So now I can make my substitution. So sine, so that's going to be u squared, and then this and that get replaced with du.
And then you can integrate it.
Now I can integrate. So this gives me u cubed over 3 with the 1/3.
Then you plug in u.
I can't cancel. I can multiply. So I have 1/9, and then I plug in sine of 3x cubed. And then go back in and cancel or mark out. So 1/9, plug in pi over 6, that turns into pi over 2. So sine of pi over 2 cubed. Plug in 0, so that's sine of 0 cubed. So what is sine of pi over 2? 1. And what is sine of 0? 0. So I get 1/9.
Why did you sine of pi over 2 instead of pi over 6?
Because when I plug pi over 6 in here, the 3 pi over 6 turns into pi over 2.
Can you explain how you did the derivative of sine 3x? It's been a while.
So I've got to take the derivative of the outside, which gives me cosine. The inside has to stay the same, and then I take the derivative of the inside, so the derivative of 3x would be 3. Anything else on that? It's all about not getting in a hurry. You got to take your time on these because there's plenty of places to mess up. So I want to integrate from negative pi over 8 to pi over 8, cosecant of 2x times cotangent of 2x dx.
Can you change cosecant cotangent to something different? Or no.
I mean, you can try that, but that's not the route in this case.
But they're the same. Then nothing has a.
Can you pick and choose now what you're inside?
Yeah, like there's no exponent or.
It's 2x.
What did you say?
2x.
2x's are inside.
Because we understand that.
Because if I make 2x my inside, that means I'm dealing with cosecant u, cotangent u. Do I know how to integrate cosecant, cotangent?
How you guarantee yourself we know how to do
Yes, I know how to integrate it. So that's how you pick and choose. I would kind of what you always start with what's the most obvious. This is the most obvious of being inside of something. So I try that. So on that last problem, it was 3x, I believe. I tried 3x, it didn't work, so that means I had to try something else. So I would always start with the most obvious, and then if that doesn't work, move from there. So in this case, 2x is the most obvious thing that's inside of something else. So I asked myself, can I integrate cosecant times cotangent? And the answer is yes, we can integrate that. So that means that is my u. So my u is 2x, so that means du equals 2 dx. So then what do I ask myself?
Do you have du?
Is my derivative there?
No.
No. So I need a 2, which means I need a 1/2 out here. So I make my substitution. So that would be cosecant u, cotangent u, du. Which we know how to integrate. What do I integrate? What do I get when I integrate cosecant, cotangent?
Negative cosecant.
Negative cosecant.
Yeah. Square just cosecant.
So I substitute. So we'll make that negative 1/2 and make it cosecant 2x from negative pi over 8 to pi over 8. And then go cross everything out.
So I couldn't have started the problem out by making it negative cosecant 2x.
What do you mean?
like at the very beginning, I wanted to do what you did at the very end right there, where you made it to cosecant, where you took cosecant cotangent.
Okay, what else would you have done?
I don't know. I was just like, I saw cosecant cotangent. It's like, hey, do that. So that's what I said.
The more you practice, the more you'll know you'll be able to do. You won't have to take every single step I do. Some of us are good on step-by-step stuff, and we're going to want to take step-by-step the whole way. Some of us can see things down the road, so we don't have to take all the steps. That's just up to you to figure out what you're going to do. All right, so I plug in. So that's pi over 8 times 2 is pi over 4. Anybody remember the rule on a negative inside of cosecant?
Disappears.
It is not.
That's
Goes out front.
It goes out front, so I can change that. So that means whatever I get, I'm going to have 2 of them. So pi over 4, what's cosecant related to?
So
Sine. What's sine of pi over 4? 1 over the square root of 2, so that means cosecant is. So I put those together, that's going to give me 2 square root of 2's. The 2's cancel. We end up with negative square root of 2.
When you change the negative pi over 4 to positive, could we just do it normally? We say that's in the fourth quadrant.
Yes, you can do that. Yes.
you skipped
You go over
steps
the
and
steps.
you lost this one.
Okay, thank you.
All right, so identify that you've got a composite. Identify the inside. Take the derivative. Make sure the derivative is there. If it's not there, make an adjustment. Make the substitution. Integrate. Substitute back. Plug in your limits. There it is. So that's integrating composite functions using U substitution. Questions?